Hi, and welcome to this control flow video in which we look at instruction flow and repetition. As we've talked about before, we can think of instructions as flowing through the computer. These instructions are executing one at a time in sequence, but we can picture them as a stream that is flowing through the computer. We can branch that stream using control flow statements, but we can also add loops which get that stream to repeat instructions. And that's what we're going to have a look at in this video. This image captures the basic idea of instruction flow. Just to recap, the idea is that the CPU is running instructions and these instructions are executed one at a time. So we have instruction 18, 19, 20, 21, and these are all flowing through the computer. That's achieved by incrementing the value in the program counter, which then moves on to the next instruction. So the instructions, in a way, flow through the CPU one at a time in sequence. Using control flow statements, we can adjust the sequence to include loops in which code is repeated. So instructions flow through the computer, and then at some point it jumps back and repeats those instructions again. Let's have a look at how that works with the while, do while, and for loops. There are two different kinds of loops, but depending on where we put the condition. So we can have what we call a pre-test loop, which will be a while loop in our code. This means that the condition is before the instructions that are going to be within the loop. We make a decision whether we go into the loop or not. A pre-test loop might run 0 times. If we get to the condition, we can choose to go into the loop, which means we repeat the instructions and go back to the condition. But it's possible that when we get to the condition the first time, it's false, and that means we just go straight around. If we're looping, when the condition is false, we would exit out as well. So here's our visualization using instruction flow. We've executed instruction 19 and instruction 20 is currently executing. It has the decision of whether we're going to enter the loop or not. Now the loop itself is actually implemented over here in instruction 22. Notice this instruction is going to jump us back to instruction 20. That's what creates the loop. If instruction 20 chooses to go to instruction 21 based upon the condition, then what's going to happen is we're going to execute this loop. So we'll do execute instruction 20, 21, 22, which will then jump back to instruction 20. Evaluate the condition again, in which case we go back into instruction 21, instruction 22, etc. When this is false, the condition that we coded there is false. It will jump over the instruction 22 and go therefore onto the next instruction in the code. So while we think, this code is going to run while this is true, there's no magic that checks whether that's changed while the code is running. All that is happening is we're making a decision at the start of the code to say, should I run this loop? If that's true, we jump into the loop, we run through the loop, and we jump back to the instruction. It's only when we get back to that decision instruction that we check that condition again. And we check, has that condition changed? And if it has, so maybe it's false now, in which case we jump over the instructions and we jump out to instruction 23. Here's an example of this using a while loop in our code down here. This lets the user enter a target and will then loop this variable I while it is less than that target. Let's step through this code now using our tracing ideas. So the first instruction that's going to run is up here. It's going to create a target variable. So I'll call this one here is my target variable. So that's target there. Now we don't know what the value of target is because it's not yet assigned a value. We come down here, we write it out, we read something from the user and we convert that to an integer and then we store that in the target. Let's say that the user entered the value 3. Okay, there we go. So value 3 is in the target variable at the moment. The next instruction creates a variable I. So I can draw my box here for I. And that's going to represent my I variable. Now we do have an assignment here. I is assigned the value 0 at the start. So I can say I has the value 0. Okay, what's going to happen next? We get to the while loop. It checks the condition. Is I less than target? What's I? Is 0 less than 3? Yes, 0 is less than 3. That means the code will choose to enter the loop and execute the loop's instructions. We'll print out the value. So we're going to see 0 printing out. So this can be my terminal over this side here. So 0 gets printed out and we do I++. So you remember I++ is the same as I is assigned the value I plus 1. So what's I plus 1? 0 plus 1 is 1. I store that into the variable I, so it's no longer 0, it's now 1. Here we go. We get to the end of the loop. That's the I++ finish, the end of the loop, and that's where we jump back. Remember the instruction 22 jumps back to instruction 20, so that's the idea here. There's an instruction embedded by the compiler to say go back to that start of the while and check that condition again. All right, now we check it again. Is I less than target? I is 1 less than 3? 1 is less than 3, so let's enter the loop again. We print out the value, so we're going to get 1 printing out, because I has the value 1 at the moment, so 1 will print out. We go to I++, I is equal to, I is assigned I plus 1. 1 plus 1 is 2. 2 is stored in I, so cross that out. We've now got 2. Here we go. And we then loop back around. So follow the loop around again. We're back to our condition. Is I less than target? What's I? I is now 2. Is 2 less than 3? Yes, it is. We do this loop again. Print out the value, so we're now going to print out the value 2. Do I++, so this will become 3. Get to the end of the loop, so jump back to the start of the loop. Is I less than target? Now notice, I is not less than 3 at this point, but any code would have run between here and here. It's only when we jump back that we check the condition. So here we jump back, we check the condition. Is 3 less than 3? No. 3 is not less than 3, it's equal to 3, it's the same value. So we now jump over the rest of those instructions, jump over the body of the loop, and we continue running this program from here. C# also includes a for loop. A for loop is just an elegant way of putting together all of the bits of a while loop. So here we have the code which initializes the value of the variable we're going to use to control the loop. In this case, the variable I is being used to control the loop because we're looping while I is less than a target value, and that target value doesn't change. At the end of the loop, where we had the I++ before, now gets coded up here. And so this lets you see quite nicely together the initializing of the loop. So at the start of the loop, when we enter for the first time, we're going to do this bit of code, int I is equal to 0. The condition is then this middle bit where we say, is I less than target? And if it is, that's where we decide whether we run the loop or not. And then at the end of the loop, when we get here, it comes back, checks or executes this instruction here, and then checks the condition then. So we could trace this like we did before. It's exactly the same while loop, but just to see how it works, we get our target. This time I'm going to choose the value 2. We get our variable I, so here's I. We assign it the value 0 when we enter the for loop here, so 0. We check the condition. Is I less than the target? Is 0 less than 2? Yes, it is. So we go and execute our write line. So the value 0 prints out, the same as it did in the while loop. This is the same code as the while loop in effect. It's just written using a for loop. We get to the end of the for loop. It jumps back now to this iterator, the bit of the third part of the for loop up the top here. It does the I++. So this now goes to 1. 1 is less than 2. So we enter the loop again based on that condition. We print out the value of I, 1. Get to the end of the for loop. We jump back to the iterator here, which is going to increase the value of that. So the increment there. And we get the value 2. 2 is not less than 2. So this condition is now false. And because that condition is false, we jump to the end of the for loop and we continue going. So any for loop that you create can be written using a while loop. It's just a matter of this code goes before the while loop. That is the condition in the while loop. Also this code here, the int I equals 0, is before the loop. The I is less than target is the condition, and I++ is the last instruction in the loop before it jumps back. So all of that so far has been about the pre-test loop. The other kind of loop is the post-test loop. The difference here is that we're going to have the instructions before we get to the condition the first time, and then we choose to jump back to the first instruction and execute those again. In terms of our visualization, it would look like this. We have instruction 18 and 19 that have already executed. We get to instruction 20 and it does the check. Now this is where we implement the loop now. Instruction 20 checks, and if the condition is true, we're going to execute this again. It jumps back to instruction 18. So instruction 18 runs, 19, 20, jump back. 18, 19, 20, jump back. 18, 19, 20. When this is false, it then lets that it lets that continue on to instruction 21 over here. Here's an example of how that would work in C#. The way we would do this is with what's called a do-while loop. We need some indicator at the start to tell the compiler we're about to create a loop. So that's the do part of the do-while loop, and then the while has the condition at the end here. So this is a do-while loop. Here, let's trace through this to see how this works. All right, so here we create, when this executes, so with our hand execution, we can see that we create an again variable. So I can put my again variable over here. There we go. We then enter the loop. It's going to print out hello. So I'll just write H there. Hello. It's going to print out again. And then we're going to read in. So let's say that the user enters Y. So we read that in and we store that into the again variable, as I've already done, and we can check. So we say now while again equals Y or again equals Y. So does again equal Y? Yeah, let's pretend that's a lowercase y, it looks like one. Then that's true. Because that's true, we're going to repeat the loop again. So then it will go back up. We'll print out hello, we'll print out again, and then we read in our new instruction. Let's say I do my uppercase Y now, so it's no longer has the lowercase y value, it has an uppercase Y value. We get back to the end, we check our condition. Does again equal Y? No, it doesn't. Does again equal Y? Yes, it does. All right, jump back, repeat the instruction. So it's going to print out hello, it's going to print out again. I type in my new value. This time, let's say I say yes. Yes. Yes gets put in there. So it's the string yes. It's going to come down here. Does yes equal Y? No, it doesn't. Does yes equal Y? No, it doesn't. So that means that code will exit. And that's an important thing to note here. This is only going to check, does all of the text equal Y or does all of the text equal Y? We would also be able to exit the loop by saying N for no, for example. But if I type in yes, that's not Y, just Y, so therefore it would exit as well. So that's looping and repetition. It allows you to repeat code a number of times. We have a pre-test loop and a post-test loop. So which one do you use, the pre or the post? Most of the time people choose a pre-test loop. So while loops and for loops are used much more than do while loops. Why is that? A while loop or a for loop can run 0 or more times. A do while loop runs 1 or more times. That means you can sort of always use the while loop. If you make sure the condition is true the first time, you're going to get at least 1, and then it might loop more times. So people just tend to use the while loop more. Do while is nice. If you have a case where you want it to, or it reads more easily in the code, you can use that. So it tends not to be used as much. I hope you enjoy exploring repetition and looping. Enjoy the journey.